All right, so suppose we wanted to solve 9.1 number 31, which says solve tangent of theta is minus root 3 over 3. Right. Okay. So what do I do?
I rationalize the denominator.
Oh, okay. So it looks as though a denominator has been rationalized.
All right.
Whatever those words mean.
Oh, I understand that. Right.
Of course you do. So I think there's a negative, right? And then what did they rationalize to get this thing?
1 over root 3.
1 over root 3. Okay, so can I see that in my standard triangle someplace?
Cosine theta over cosine theta.
Okay, so you could look at tangent theta and think that's sine theta over cosine theta. I think that's probably overkill. I'd probably look at tangent and think TOA. Oops, how do you spell TOA?
You can't use the calculator because it says find exact solutions.
Good. Yeah. So if you punch this in a, if you punch it in a calculator, depending on the quality of your calculator, this will either give you the right answer or an approximation.
It gave me the right one.
Yeah.
That's
So
awesome.
I would. I still think we could probably think our way through this. So I would think, what standard triangle do I have that has a 1 and a root 3 in it?
30, 60, 90.
The 30, 60, 90. Okay, so I pull the 30, 60, 90 triangle out of my pocket here. 30, 60, 90, and what are the sides?
1, 2, root 3.
1, 2, root 3. Okay, so for which angle, right? That's really, right? For which angle theta is OA, right? 1 over square root of 3.
A cosine
So,
or 30 degree.
okay, so from 30 degrees,
Yeah.
right? What's the opposite?
1.
1, and the adjacent's root 3.
Yes.
Cool, check. So I found 30 degrees has tangent of 30 degrees is 1 over the square root of 3, right? That's what I just found from this triangle. Am I done? Is 30 the answer? Oh, crap. So it's supposed to be negative. Mine's positive. How do I account for that?
Different quadrant.
Yeah, quadrant. So what's my go-to tool for sorting that out?
Unit circle.
Okay, let's get out a unit circle. Okay, so I got out my circle. And now I need to embed this in there, right?
Second quadrant.
In such a way that,
It could be the second quadrant.
ooh,
It can be the second or the third.
okay, so I need a triangle, right? So I'm going to put a triangle in quadrants, maybe. Right? Like, what the heck? Let's put it in all of them, and then we'll sort out the ones that match. So I got my 30-degree angle here, and this has a 1 and a root 3. Okay, that one's positive, so it doesn't work. How about here where my angle's what?
Negative 5 over 6.
Perfect. Negative 30 degrees. What are the sides there? They're root 3 along the adjacent and
Negative 1.
negative 1 on the opposite. Oh, that one works. You guys with me? Okay, so I got negative 30 degrees is one of the things that's kind of going in my box for later. What else? If I'm here, what's the angle for that one? That's a 30-degree reference angle, right? But how do I actually get there?
150.
Perfect. 150. You guys with me? Okay. And that, why is it, oh, negative root 3 because I'm going backwards in the x direction. And then this side is 1 log. So I got
1
1 over negative root 3, which works.
Yeah.
So I got 150 is okay. All right, then how about this other one down here? Yeah, that's a negative 1 and a negative root 3, so that one is positive. So I don't need to worry about where that thing is even, right? Okay, so are those my answers?
Yeah. No, because then you can go around the circle a bunch of times.
Oh, crap.
Yeah.
Right, so I have two answers, right? You guys see that? But maybe graphically, right? I'm trying to solve tangent of theta is something. What does tangent look like?
Zebra.
Yeah, it's zebra stripes, right? So we have lots of these. Oops, that one got shitty. And I'm pegging some value, right? That value is negative root 3. So, or negative 1 over root 3. So that's some negative number like this, right? So I got 1 here and 1 there. That's my negative 30 degrees and my 150. But what about this one and that one, this one and that one?
You cut them off with the inverse tangent.
Yeah, I cut all those off when I kind of thought about inverse tangent, right? You guys see that? Okay, so how do I straighten this out? What do I need to do?
Add 2 pi, and the number has to be a positive integer, or it has to be an integer.
Okay, so I want to take my two answers, right? My minus 30 and add 2 pi n's, and we'll just assume n is an integer.
Can you just pick one of those and just add pi?
Oh, that's an even better idea. Yeah. So I'd probably pick, if I was phrasing this in radians, which it sounds like, I'd probably pick minus pi over 6 plus pi n with n in z. Cool. Why can I get away with the pi instead of this 2 pi?
Because it's happening every 180 degrees.
Yeah, the
Same thing.
period, right, is 180 degrees. And if I did this with arctangent, right? Like if you punch arctangent in your calculator, you're going to get that minus 30 degrees. And then you have to account for the rest of the periods that you've cut off by restricting the domain of tangent. Questions, Steele? That's straighten you out, Candace.
Yeah.
Was
It's
it
a little more complex than that.
was it this thing that was dark in you? Or?
Yeah, I was lost on the problem in the first place, and then I asked some help, and just totally lost me when I saw the help.
Okay. So one thing you, like an alternative approach that maybe would have
All
yielded
erased.
answers quicker is to take this whole equation and hit both sides with an arctangent. So that'll tell you theta is the arctangent of minus 1 over root 3. And then out of your standard triangle, you're going to figure out that's minus 30 degrees. Right? And then you'll have to do the, okay, well, theta-ish, right, is minus 30 degrees. I'm really just going to need an ish too. And then you want to draw that little picture and account for zebra striping. Cool? So yeah, I guess I'm saying that's easier, but that really amounts to me just saying it faster, not providing any